x and bar up. That one is what we are calling mean. That's the mean. If you see this one x, or if they tell you calculate the mean, you can put this one. So mean is defined by our x bar is given by summation of x out of n. Summation of x out of n. That's the value of mean. Or that's how you find the mean. Where x is the variable given, where x is the variable given, and n is the number of variables, and n is the number of variables. And n is the number of variables. So that's the mean. For example, if x is equal to, let us say 1, 2, 3, 5, 6, 6, maybe 6 and 7. If x equals 1, 2, 3, 4, 5, 6, we can even stop at 5, or at, yes, 5 will work. 1, 2, 3 and 5. So, and we say find the mean. Find the mean. If x is given by 1, 2, 3 and 5, and then the equation is saying find the mean. Find the mean. But we saw that mean is given by summation of x. This symbol here, it is meaning summation. Otherwise, we are adding from order to this one is summation, which is meaning that adding the number of variables which are there out of the total numbers which are there. So here we shall look at, now we have said the mean is given by summation. So they have said mean is given by summation of x out of n. So what is our summation of x? Summation of x equals to, these are the values. We are going to sum the values of x. Okay? We are going to sum these values of x. Now we are going to sum, that one is the same as summation of x is 1 plus 2 plus 3 and then plus 5. Our answer is giving 1 plus 2, 3, 3 plus 3, 6, 6 plus 5, that is 11. So what is our n? Our n, we say, is the number of variables. Where is our variable? Our variables is 1, 2, 3 and 5. So what is the numbers? We just count. This is 1, 2, 3 and 4. The variables are 4. So this one, our n is 4. So now our mean become summation of x, which is now 11, out of 4. What do you get? 11 divided by 4. So let me use my calculator and get that one to be sure. Divided by 4. This one we shall get 2.75. The answer is 2.75. So that's how we calculate the mean for ungrouped data if you are given variable x. If you are given variable x, we use that one. Okay? Now, that's the first step of calculating the mean. The another step if you have given assuming the mean, if you have given assume the mean, if you have assumed the mean, or if you are given assume the mean, which is the same as if you are given assumed the mean. If you are given assumed the mean, sometimes you call it working mean. If you have assumed the mean, our working mean is denoted by A. Assumed mean or working mean is denoted by A. So if you are given assumed mean or working mean, how do we get the mean? If you are given assumed mean or working mean, how do you get the mean? The mean is defined by our mean equals to, if you are given assumed mean, we don't get mean the same way we have been getting for the other values. What do? We get assumed mean, which is given, plus summation of D out of the number of variables out of N. So our D, but we know that our D which is the deviation, is given by x, minus assumed mean. D is given by x minus assumed mean. So where x is the variable and a is the assumed mean, this one is the deviation, which is defined by this one, x minus a, and then our mean is given by assumed mean plus summation of D out of N. So after getting the deviation, you add the N, the numbers of D. If you have assumed mean as 5, and then our x is, okay, let us assume that our assumed mean is 5. Example, given x equals to 1, 2, 3, and 4, and assumed mean Assume the mean is 2. Find the mean. So now with this one we have solution. What we need to do, we go the table having the values of x, which is 1, 2, 3, and 4. Then after having value of x, what do we want? We want to get d, which is given by x minus a. Here we can have x minus a, which is d. Okay, our d equals to x minus a. So, but we know that our a equals to 2, then our x are here. So if you get x minus a, you start 1 minus 2, you get negative 1. 2 minus 2, you get 0. And then 3 minus 2, you get 1. 4 minus 2, you get 2. So you get here the summation of d, which equals 1, negative 1 plus 0, you get negative 1. And then negative 1 plus 1, you get 0. And then what will remain? We get 0 plus 2, which is 2. Then we said our mean is given by, assume the mean, which is a plus summation of d out of n. Please note, summation of d, this d is the only one out of n. Assume the mean is not affected. We only have x out of n. Assume the mean d out of n, but not a. So our a was 2 plus the summation of d, which is still 2 out of n. N is 1, 2, 3, 4. So our n here is equal to 4 out of 4. Then here we follow the rule of BODMAS, which I get 2. 2 plus 2 divided by 2, we get half, which is 0.5. So this one, what do we get? We get 2.5. We get what we are calling, so our mean x bar become 2.5. That one become our mean. That's how we calculate the mean given the assumed mean. So let us look at the mean given we have the frequency. If you are given the frequency and you have the assumed mean, if you are given the frequency f, if you are given frequency f, mean is defined by Mean is defined by x equals to summation of f x out of summation of f, where summation of fx is frequency times x and f is the summation of those frequency. And also if you have both frequency and the assumed mean, if you have both frequency and assumed mean. If you have both frequency and assumed mean, we say the assumed mean is A and frequency is F. So how do we define our mean? Our mean is defined the same way, but instead here we shall change our x bar, which is assumed mean, is given by A, which is assumed mean. We say the assumed mean is not affected by division. Plus, now we shall instead have summation of fd. There we are having summation of f only, but here we shall have summation of fd out of summation of f. So this